Till date, we have worked on cantilever and simply supported beam. Now let us solve some problems related to the beam. Here in front of us, we have a cantilever beam on which various loads are applied. We have to draw shear force and bending moment for the beam. Here is the beam. This is the cantilever beam in which a uniformly distributed load UDL is applied, which is of 2 kN per meter amount, and a point load 1 kN is applied at point C, and another load 5 kN is applied at a distance of 1 meter from A, which is clearly visible in the diagram. Now let us start solving this problem. In the diagram, as we have seen, this is the diagram. A section between DB XX is considered, which is at a distance of small x from B. So now let us start with the problem. As we have seen above in the diagram, that some section XX is considered at a distance small x from the section B. Now we have to find out the shear force between B and D. B and D. So let us start. Shear force at X. In the above diagram, the shear force at X will be the W into X. That is the load multiplied by the span. So shear force at Fx will be W into X. Now at B, our X is 0. So shear force at point B will be 0. So here it is written as Fb is equal to 0. Now we can find out the same shear force at a distance of 1 meter, which is shown. X is equal to 1 meter. At X is equal to 1 meter, we can also refer this diagram, which is same what is given in the slide. So in the figure it is clearly visible that point D is at a 1 meter distance from B. So now here we will start FD. Just right part of D, our shear force will be 2 into 1, that is 2 kN. Now shear force between C and D. Up till now we have worked for the shear force at point B, and now we will work between D and C. Here is the same diagram. The point C and point D are clearly visible. So you can keep in mind that where the point C and D are lying. The point D is at 1 meter from B, and point C is at 1.5 meter from B. So we are at shear force between D and C. It will be W into X plus 5. 5 is the point load applied at D. Now at X is equal to 1 meter, FD, the amount of FD, it will be just left. We will calculate it adjust left part it will be 2 into 1 plus 5, that is 7 kilonewton, and at x is equal to 1.5 meter, that is at FC, just right side it will be 2 into 1.5. 1.5 is the amount of x plus 5 is equal to 8 kilonewton. Now we will find out shear force between C and A. Shear force at x distance, it will be Wx plus 5. 5 is our point load plus 4. 4 is also our point load. At a distance, if we will consider x as 1.5, FC just left, it will be 2 into 1.5 plus 5 is the plus 4, they are the point load, so it will be 12 kilonewton. We will put this value in shear force between C and A. Now in the same equation, Wx plus 5 plus 4, we will put x is equal to 2. So Fa will be 2 into 2 plus 5 plus 4, so it will be 13 kilonewton. So these are the value of shear force just to the left side and at A. Now for this value, we will draw the shear force diagram. This is the shear force diagram clearly visible. As we have seen that at point B, we find out the shear force as 0. So it is kept as 0. Since the load is UDL, so an inclined line will be drawn between D and B. Then again an inclined line will be drawn between C and D. And again an inclined line will be drawn at C and E. So this is the shear force diagram. This is the shear force diagram between A and B for the above loading. Now let us start calculating the bending moment for the same beam. Bending moment between A and C. Between A and C at a distance of Wx. At a distance of x, the moment will be W into x into x by 2. It will be negative in nature. So our moment will be Wx square by 2. Now for the point load of 5 and for the load of 4. Our moment will be Wx square by 2 minus 5 into x minus 1. X minus 1 is the distance between DB, and minus 4 into x minus 1.5. 1.5 is the distance between C and B. So at x is equal to 1.5. At x is equal to 1.5 means we can refer this diagram. At x is equal to 1.5. Again look at the diagram and clearly keep it in mind that we have 4 points in the cantilever beam, that is A, C, D and B. The distance between AC is 0.5, between CD it is 0.5 and between DB it is 1 meter, and the loading. So again come to the shear force. Shear force at point C, which is nearer to the point A. So it is at a distance of 1.5 meter, clearly seen in the diagram. So the value of movement at C is denoted here. It is minus 2, that is the UDL, into 1.5 square, that is the value of x divided by 2, minus 5 into 1.5. Here in the equation, x minus 1, x is kept as 1.5. So here it is written as 1.5 minus 1. Minus 4 into 1.5 is the distance, minus 1.5. So we obtained the value of movement at point C as minus 4.75 kilonewton meter.